I'm Beverly McCarter, and I'd like to introduce your AI panel. We'll start with Dr. Jeff Wilkinson. He's the Chief Scientist of, and I may mispronounce this one, so I need your help with this, MIMIC.
In modeling and simulation, you mimic.
MIMIC. Okay, thanks. Prior to retiring from the U.S. Army, Jeff served as senior operations and training positions at both the Armor Battalion and Brigade levels. He's the Director of Simulations at the Armor Center, where he led the concept development and experimentation in one of the Army's first virtual reality test bed facilities. At the Sprint Corporation, Jeff led design teams developing integrated solutions for converged broadband applications. As a research scientist at Texas A&M, Jeff served as the U.S. government's program manager for the USC Institute for Creative Technologies. Jeff's primary research interest is in the design, methods, and processes required to ensure virtual reality systems enable effective training. Dr. Gregory Harrison is also on the panel. He's the principal investigator in internal research and development at LMGTL. In his 28 years at Lockheed Martin Corporation, he has contributed to the modeling and simulation business in real-time flight and constructive simulation mathematics and implementation, discrete event simulation and dynamic simulation complex systems, as well as authoring many papers and patents for modeling and simulation, control systems, artificial intelligence, and complex adaptive systems technology and implementation. He has led the creation of adaptive simulation characters using genetic programming and learning classifier systems. He is currently researching augmented reality technology. He's a member of the graduate faculty at Florida Institute of Technology as well. We also have Brian Stensrud of the research. He's a research scientist and head of Orlando operations at SoarTech. He received a PhD in computer engineering from UCF in 2005 and has been at SoarTech since 2003. Formerly a behavior developer, Brian currently serves as principal investigator on a variety of research efforts applying artificial intelligence technologies for training. His current research interest involves strategies and techniques for composing, integrating, and evaluating intelligent agents in a virtual training environment. Now, not to be the least of the last, this is Corey Crum of Havoc, and I'm going to let him introduce himself because he is incredibly exceptional.
Oh, thank you. Really the reason for this is we were missing my biography, but very quickly, I am responsible at Havoc to adapt games technology for the needs of simulation. Prior to that, I was working for Prestigious as part of their R&D group with focus of human simulation around artificial intelligence and other ergonomy type of applications. And then the reason why I have why I'm on this panel actually stems from some of my work many years ago. Actually, I was one of the founding members of a product called AI Implant, which was pathfinding middleware that was used heavily in film and games. And then that company, I was acquired into the simulation space through an acquisition, and then I became part of the simulation community, applying that knowledge to simulation. So from that, what we wanted to do today is a little bit different. We wanted to involve the audience in a series of questions to find out what type of simulation needs that you have, what type of AI that you might want to be looking for inside of your training applications. And then we can give answers to what we believe could be relevant from the questions that we have here, or we can just argue amongst ourselves about what might be the right approach for some of these questions, if you're keen on that. So I guess we can jump right in. The very first question that I have here on the list would be, what type of requirements do you see for behavioral AI in training and simulation? Any takers on that question?
Conversation.
Conversation. So conversation between NPCs or conversation
Between a user and an NPC.
Okay, so what's the goal? What are you trying to achieve?
Let's say you're trying to do certain tasks that require cultural awareness.
Okay, and what's the input?
What's
Text?
the input? How about let's go with let's make it easy. I'll say text.
Okay.
Natural language.
Natural language processing.
Yeah.
Okay.
You made it easy with natural language text.
Yeah.
The text part versus the voice part is that's largely the easy part. It's when you put the natural language part in there, it turns it into the.
Yeah, I know. But I didn't want to have us go. Let's short circuit at least that easy part.
So, at least from my perspective, we SourTech typically deals in reasonably high fidelity agents and a lot of them involve interaction via speech from somebody that's giving them commands or asking them for reports or what have you. The way that we deal with that in the agent is that you'll have a speech system or a text system that is attached to a toolkit that kind of circumvents the natural language problem, has a grammar on top of it. It's typically confined by the domains of air traffic control, commands back and forth from soldiers, those sorts of things. So you kind of bound your natural language problem in a grammar that's specific to a domain. But what you need on the other end of that, so with that, essentially you can then interpret what the text is, right? You can say, okay, I've said something, and what does that mean? What are the elements of that? I give you a command, that command means something, what are all the elements of that command, what are all the elements of that? But what you need on the other end, the other part of that, is that you need the system on the other end to be able to interpret that in some intelligent way, right? Instead of just responding to something that has happened or some sort of command, it's got to be able to parse it itself and understand what the question was, what the command is, and if it's really smart, understand it in the context of what it's doing. So we have quite a bit of examples of that, so specifically in the air domains of a system that can interact with an operator, an AWACS controller, or what have you, be able to interpret what it's doing in terms of its goals and then responding back. So there's quite a few examples of that. When you get into culture, there's obviously the language piece in there and all that sort of stuff. So getting beyond that, there's certainly ways if you bound the problem that you can. Bounding it means getting away from the natural language, because that really is kind of a whole separate issue. That's there's billions and billions of dollars of resources going into solving that problem. So you can kind of circumvent that a little bit and still be able to get some good AI on the other end. So I'll stop talking.
Well, maybe one comment there. I think this is, for me, this is always kind of an area of general interest. So when we know the roles and responsibilities of the person that needs to communicate with another agent, I think that that narrows the scope of the problem, and that's great. But in general, if you have an unbounded system, and if you have less information about kind of the roles and responsibilities of the agent that needs to communicate with another agent, is there anything today that could attempt to solve some of those problems?
There have been examples over the past couple of decades with what's called agent communication languages. So basically it provides you a format of this is how agents communicate with each other.
That's machine type.
That's right.
It's not natural.
It's not. It's at least a common protocol that they can use to be able to understand what they don't understand.
So you'd have to dissect what the person said to begin with,
right?
And try to. Like the speaker in the last lecture on the edge was talking about being able to see different sentences come up, and you can determine whether this was a friendly sentence or a non-friendly one. You can probably take the actual terms that are spoken and search your vernacular to find out what they mean and try to find a good response. And that's one way of communication where you have the you talk to person, maybe unstructured, but then there's also like a mission communication where you talk to the air traffic controller and you call in a helicopter attack and you have to give them a 9-line.
Right.
And at that point, then that sets off a whole architecture of messaging and intelligence that carries a whole scenario from start to end. You have to do your part. Then something else, something goes wrong with the simulation.
Well, those sorts of situations are, when you have 9 lines and stuff, that's kind of tailor-made for speech type applications. Because at least your domain descriptor, air traffic control, largely, 711065, and there's a whole manual about this is how you text within there, but a lot of those kind of domains are structured in such a way that those are good targets for those type of applications. In my opinion, it's when you get into some of the cultural stuff where you're carrying on those conversations where you're going to have big problems. Because people can say pretty much anything. From the 9-line, at least you say this, and then you say this, and you wait for a response.
Yeah, so I guess then, are there other types of use cases? So we spoke a bit about language processing, communication type of AI. Is there other types of AI that you'd be interested in?
Yeah, I think one of the things I'd be interested in would be, I guess, the different types of AI, but when you think about big data analytics and how that can, from an intelligent tutoring perspective, how that can drive down into driving the AI that's inside of a game or a serious game, and the potential for standards that might be able to be applied across the board so that tutoring systems can interoperate, if that makes any sense.
I have heard of one system that one company I worked with in past was trying to define some standards. And like XML, there's a lot of use out there of OWL, actually, to be able to define some way of communicating between disparate systems. I don't know how far that research went, but that might be an area to look into.
A lot of tagging would go on. There's one company that does the intelligent tutor system. And they've recorded tutoring sessions, thousands of them. They're all in speech. To get them into computer, you need to tag the information with some type of indicators. Now I'm talking about mathematics. Now I'm talking about AK-47 or something like that. And the individual subtags and maybe what you're dealing with to provide a tutoring session that you could perhaps pull out of a box and present to the user. Or do you want to have a real life tutoring session?
No, I'm thinking more of an automated system. So when you talk tagging, I guess you're talking more machine readable system, something like that, instead of standard human readable metadata. Right?
There's a lot of tags, things you can search through, Bayesian inference as to what type of tutoring session this person needs. Maybe an upfront interview with them to see where they're at with their current knowledge, so you can tailor a session for them.
One of the issues you have with standards when you're talking about AI is that there's lots of different ways to skin that cat on the other end. So I read your bio, you're doing a lot of stuff with genetic programming and genetic algorithms and stuff like that. So that's one way of representing a problem. The way that we build AI systems is pretty much on the other end. It's all symbolic and it's all goal-based reasoning kind of thing. So in a lot of senses, the data that we're looking at is in a much different kind of granularity. So really, the best that you can do to kind of have those kind of systems kind of marry is have kind of common protocols, right? So maybe so say you have an output of your genetic algorithm that's going to say something, right? You're still going to say that result needs to come to maybe our systems are married somehow, right? And I go out and I make a call out to you and say, hey, I need to solve this recognition problem or something like that. And I need you to give me an answer so that I can use that to properly provide good feedback to my user in the context of an intelligent tutoring system, right? How do you get that data to me, right? Is there some kind of a standard that exists, some sort of I don't want to say HLA, because I just don't want to say HLA, but those types of protocols that you can at least format your outputs and give that to me in a format that I expect. And there are some examples of that, or at least connecting systems to virtual environments. Brett, are you familiar with a protocol called JBus?
Yeah.
So we've actually had quite a bit of success connecting some of our AI systems into some virtual environments using that protocol. Being able to get good responses back from our game engine and pushing it back, and then also being able to communicate with other disparate systems. I think those sorts of things. But if you're talking about the way that the AI is thinking about the problem, standards are really not going to exist too much in there, because there's still a lot of Minsky yell about this all the time, is that everybody's solving AI in kind of a different way and they have different representation stuff. So I think the best you're going to do with standard is going to be in those protocols about how they talk to each other
Another question in the back?
Well, I'm curious as to your view of the state of the art of the body language being used and how important you think that might be.
Well, if you're training your agents with genetic algorithms, the trick there is if you see a certain body language, you can choose to respond to it. Or the agent would choose to respond to it. It might choose to shoot, to say something, and the idea then is that it learns from a response. So your body language is not really put into text. Somebody could interpret it as, well, they're looking, they're swaggering, or they're arrogant, or they're pleasant, or something. But in reality, it's just a geometric shape. How you respond to that geometric shape on the avatar could be, well, in a normal person, it's learned. If you go and you run across a room screaming, your mother's grabbing you and she says, don't do that. So the idea here, if you're going to have a GA avatar learn it, you have to give it a reinforcement function to see if they're going to have, if you've done the right response, and then you do that response later. So it's more than having to interpret you into a particular verbal interpretation of your stance.
No, I was thinking of a response, but not necessarily verbal.
No, not going to be verbal. It's going to be, I see this, it triggers a couple neurons, and I am going to assume a different stance. Maybe cross my arms or something, but it's not really verbal. It's more machine. And it might trigger a different set of flow through the pathways of your intelligent, learned behavior.
Well, maybe another aspect to consider is what is the state of art of the input data? So you have organic motion that, finally we have sensorless motion capture. So we have a way of getting some data in that a real person is gesting. The interpretation of that would probably be very limited because we're just now having game consoles that can turn that motion into a skeleton and try to predict what the motion of the skeleton is to kick a soccer ball into a goal in a game. So the input is still very, very limited with low resolution. And until we have almost prediction of what the input can be, it's hard to turn that into something meaningful in AI.
Speaking for me, the characters that we've integrated into virtual environments, it's hard enough to be able to get the information of whether the guy is standing up or kneeling or everything like that. So just being able to have access to some of that information would be very useful, much less arms crossed or furrowed brow or anything like that. Right? That would be super. AI can take advantage of that kinds of input if it were available to us to have some sort of sequence. But certainly in any kind of a system where you have conversation or anything like that, that information is almost as important as the dialogue. So.
And most game-based AI is they cheat the system. It's advanced choreography. So if you have a fight sequence, close combat, what's happening is someone, before they hit the person, they say, I am going to strike you with my left arm. And then they play back the appropriate response. So it's a very, very limited experience. It's a very controlled experience. While it looks compelling, it looks very intelligent in actuality, but there's not much going on behind what you're seeing in the graphics.
It doesn't have to be there.
It doesn't have to be, but that's a lot of what's happening
It takes
now.
a lot of work to make that generative.
Because if you're able to sense the person's stance, you could issue a command to let loose a right hook at the right time, perhaps to take care of the situation. And if you do it enough times in play, you'll learn that whether you've done it at the right time, if not, and you get rewarded in that case in this type of reinforcement learning, adaptive behavior, so that if you actually knock the guy out, you get like 1,000 points, and if he knocks you out, you lose 1,000 points. You play the game over 1,000 times, and then you develop a behavior that way, as long as you're able to learn from your actions. That's another aspect of the game tech environment. I think that I don't know if it's a selfish aspect or whatever, but we're talking about using the artificial intelligence to train us, but we can also, the artificial intelligence can use us to train it, which is a little scary when you consider it may learn how to learn you better than you know it, and you put these UAVs out there, these robots, and hopefully you can be able to pull the plug out, because I don't know if you saw that video at lunchtime, but I don't know what that was, but there seemed to be UAVs flying around, and these people hiding out in these huts, waiting until the UAVs moved away, and they ran out. Now, if those things knew your behavior better, you may never live outside the hut.
That actually leads into the next question, which is really good. Is that what is the level of autonomy
Wait.
that you want?
I just want to comment.
Actually, two comments. One of them, the notion of the AI learning from us, I may not have the details right, but one of the DARPA challenges for the autonomous vehicle race, I forget which university it was, but they won it hands down. And what they did was use human driving of the vehicle that the computer monitored under all conditions and learned how humans avoided obstacles and drove the vehicle under all of these cross-country conditions. And from that, learned its behaviors for how to drive the robotic vehicle.
I'm pretty sure that was Stanford.
Thank you. I was thinking it was Stanford, but I couldn't remember the university. And just won hands down based on copying and learning what we were doing. But my earlier question I was going to ask is, how many here are familiar with the human tactical questioning trainer that the Army has out now that uses interactive avatar, interactive conversational agents to train them? I know some of you are, but you're talking about the emotion and et cetera. Part of what's built into that model of it's not an avatar, it's an NPC, but part of what's built into those full-size, human-size training computer-generated items are in fact pretty high-fidelity emotional responses, gestures, etc., that are programmed in as part of the overall system for how to respond, either in a positive or a negative way to the kind of interaction they have with the trainee that's ongoing. What isn't clear to me, based on my historical knowledge of this, because it isn't recent knowledge, is whether or not the computer-generated characters are getting input via Connect or some other way of what the human trainee is doing. I know that research was underway in order to capture the human trainees' gestures, where they're looking, facial expressions, etc., in order to make that part of the input into the computer-generated character just as much as the speech was, or the emotion inflection in the voice was, or the words that were being used.
Thank you all very much.
I thought it was both ways.
Right now for that thing that we're participating on.
So the next question would be the level of autonomy. So if we're talking about a training environment, to control the experience for the end user, oftentimes it's easier to create a scenario or to guide a person through the experience in a very, very controlled way, but that's also contrary to a lot of what AI tries to do, which is to open up the experience, to have free play type of environment. So from the audience's perspective, what is the level of autonomy that you think is appropriate for a training experience? Should the AI be able to do everything they want to learn, and after the first trainee, they're so experienced that they beat every future trainee? That certainly wouldn't be a viable training solution. Or is the completely autonomous character something that you want maybe tertiary, So the main goals of the training system are very, very controlled experiences, but to have a nice immersive experience, you can have a lot of autonomy as it's maybe less critical to the training experience. Are there any thoughts on that?
So your example that you just said is something that's, so Bev and I are actually working on a project where that's exactly what's happening, right? Where you have a controlled experience kind of at the central thread of what's going on in a town, but around it are a bunch of characters that have a lot more of an open-ended kind of autonomy that they're allowed to just go and do what they want, kind of these pattern of life style agents that represent, here's clutter in a town. There's a main storyline, and most of that is scripted, much like a game would be, but around that is a lot of different characters where you have a little bit more free reign about what they're doing, just because they're not critical path, right? That they're not going to necessarily lead you through their autonomy through a path that doesn't bring you where you want to go. So.
Okay.
From a training perspective, that's actually been a great argument and discussion over the last few years in projects that I've been in, where the AI and everyone is trying to extend the capabilities of the AI to be as lifelike and realistic as possible, which means that you can't necessarily anticipate what the behaviors are going to be because they want them to be different because people are different and respond to different situations in a different manner. But as a trainer, that doesn't set the conditions for the training event to happen as it should. So there are levels of behavior, as Brian was getting to, where depending upon where you are potentially in someone's learning curve, which I think is where you were going, you would want to be able to have relatively well-controlled AI that sets the conditions for the training event, that you can then monitor and have transparency associated with what the results are. But perhaps as you get to that graduate level experience, that I call it, go from training to practice. Practice may be that level at which you now have much more free play available from the AI, where you're now testing or you're assisting the learner in practicing under conditions in which you can't anticipate what the situation will be and how. So there are actually multiple layers there.
That's a tricky thing to implement.
Yes.
We have a learning agent. How to know how to get just a high enough level of autonomy. Maybe just to switch over between learning and pre-programmed. In the control of the autonomy and like the machine learning agents usually have a supervisor that watches over the agent and tells it, either rewards it or punishes it if it does good or bad behavior, and then it integrates that, it gets rid of the bad behavior, it increases the good behavior. Maybe if there was some way to know whether you're teaching at a 9th grade level instead of at a 7th grade level. How you can do that in case it's something worse, like you're not conversing with this citizen of this foreign country at the right level. But you're right, after you get to the pro level, you can have these things generate unexpected behavior.
I would say that so representation is a big piece of this too. So we've had a lot of success recently, actually throughout our history. If you represent these behaviors in terms of what their objectives are, what are their goals, what are they trying to achieve in the world, then you can contain quite a bit of flexibility across the spectrum. So typically when we build our agent systems, we design them in terms of individual goals that they're constantly reasoning about throughout a scenario. And what you can do with that is essentially you can set up a system where they are going to be working critical path. Their main goals are to do these certain things in this kind of order, just like a script, but they're able to have situational awareness of what's going on around them. That allows them to be more flexible and allows them to have reactions to things that are non-deterministic in the world, but still be able to orient themselves towards the goal, towards the main line of action that they need to be doing as a part of the scenario. And when you have a system that's organized like that, then you can do some kind of meta things on top of it, right? If you have something that you know is a training system, Your AI characters don't necessarily have to be an AI character that's representing that person and that person only. He can be kind of either he can be kind of a meta character, somebody that's spoke the scenario, or he can be a character that's doing his own thing, but also has a goal to understand what the trainee's doing. And as a part of his behavior, he can be reacting and responding to things in a way that advances the training goal. So he can kind of help lead the trainee towards where he needs to be and kind of guide him through that experience, but not interrupt what he's planning on doing in the world.
Okay, and then I guess in that context, if we're building these types of scenarios, what is the preferred method of developing your AI? So if it's a controlled experience, is it an expert system? Is it, I mean, what from the audience would you see is the way you'd like to design your experience? Any takers?
Goal-based system sounds really good. I mean, that seems to be a common thread across all the AIs and the discovery machine people were talking about that yesterday. They have the goals, like SOAR, I guess. They had, if something happens, they have another goal that might go on a stack, perhaps that was different. And then as soon as they finish that goal, the other goals are still there. And that works out well also in the genetic program classifier system, because you have the fitness function, and the goal becomes a fitness function at that point. You satisfy the goal, you get 1,000 yen. If you don't, well, you don't get the money. So, but then if you want to do it in sequence, you have to do it in sequence to get the big payout.
The problem that you're solving is important, right? So you mentioned SOAR. Okay, I'll say SOAR. We would not solve a classification problem, right? It doesn't make any sense, right? We would, if recognizing characters or something like that, we would use something like a neural network or a genetic algorithm or something like that. It's just a better system.
Is the learning classifier system?
That's right.
That's the operational genetic algorithm.
The only thing I'm suggesting is that I don't want to. You don't want to just pick a particular paradigm and then just use that paradigm forever. Right? You want to focus. Where it's important to understand where your system's boundaries are about what it's good at and what it's not necessarily good at. Right? There's things that there's a spectrum, and we have briefs and briefs on this about where is the right place to use a cognitive architecture like SOAR, and when is it okay to not use something like that, where you want to use a neural network, where you want to use a genetic algorithm, where you want to just write a Java code, where you just want to write just a simple procedural system, where you want a script, right? There's certainly situations where it doesn't make sense to build a high-fidelity system with all these different AI widgets when you can just build a script to do A and B and C. Sometimes that's the right way to do it. It's important to identify and be able to have all those in your toolbox.
That's one of the beauty of artificial intelligence. Everything gets down to numbers, unless you're doing symbolic. So normally you can just tie these together, Bayesian, genetic algorithm, neural nets.
And they can use each other.
Fuzzy logic.
They can use each other too. A lot of them can be able to. We talked about pushing outputs from one system to inform another system so it can do its own things.
Yeah, you mentioned a way to talk between them for the communication, which wasn't just numbers. It's more like an XML script or something. That's XML.
Well, I was talking about protocol there. And I'm just thinking about content, right? So say that I want to model some person that has a variety of different tasks at his disposal. One of his tasks is to do something, right? Well, I don't necessarily want to do that using my paradigm. I want to form a specific task and have a particular algorithm go off and do that. So one of the examples is spatial reasoning. In what we do, a lot of the times when we have a spatial type task about, okay, where am I in relation to this object or something like that, or am I in this area, right? Cognitive architecture, like SOAR, is not particularly good at that piece, but we know of things that are. So we can output functions to say, hey, I need to go and get this answer. And that answer, that's the symbolic representation of that answer is something that I can go and I can go off and do something useful with, right? And that's not necessarily a piece of code or a piece of Java code or something like that. It could also be a genetic algorithm, it could be a neural network. We've done this quite a few times.
It seems like if you want, you're mentioning a centralized resource for interpreting something. Is it possible to have a resource that Here's how Arabic would interpret that. Here's how Asian, Middle East, but there'd be a different interpretation. So instead of getting one answer back, you get another one from depending on where you go. Something different a little bit each time.
Well, and what would you do with the two answers?
Well,
It
it
would
would be
seem to me that you would pass that characteristic as part of the class.
that would work.
So you only have one answer back, you have to pass the parameter.
Yeah.
Which culture you're dealing with.
Or if you're a 6-year-old asking, how far is the moon? As opposed to like a PhD, or something like that.
Yeah, so.
I was just going to say, if you're going to ask how would I want to put AI together, I guess I'd like to put it together. I'd like to have a tool. Make it easy for me to visualize. Say, I need to assemble this structure this way and go. Okay, yeah. I mean, I guess that's really the way it is. And I know there are huge numbers of ways of doing representation. I know there are huge numbers, but you're asking, you're asking, well, what do I want to do? I want to put it together and go.
The easy button.
Yeah.
It would definitely be done if it was easier. That we had a cognitive architecture, whether it's SOAR, Clarion, Actor, it doesn't matter. But have something that's a little bit easier to implement on platforms like Unity, but also have the tools to create the ontologies.
What do you mean? What do you mean implement? Build from scratch, apply, integrate?
Easier for non-programmers to understand, either a more visually represented type AI that can plug into it that could be used by SMEs or instructional designers that isn't so much coding intensive, but more representation. And also have a tool that an SME can come in and basically draft somewhat of an ontology of their domain, what their job is, capture that expert data, that expert model, so that when trainees are going in there, they know how far off they are from emulating that expert model. Well, we have no tool, we have no way to be able to go in effectively, or simply, I should say, there's ways to do it, but not simply, when you only have limited time with an SME, to be able to capture that expert data in a consistent way, to create that ontology which you can use to drive whichever cognitive architecture of your choice.
Well, so the ontology is certainly a necessary input for something like a behavior system, but it's certainly not a sufficient amount, right? So you can have an ontology of what it is that they're doing, but the interactions, a tool does not turn a non-programmer into a modeler. It helps, right? But there's lots of, lots of times it just gives them another medium under which to be confused about what to do, right? I mean, you could have all these, this has happened, and I won't mention any names, right? But there's plenty of these graphical tools out there that you can use to build models. I don't see any good models, right? They're just not there that are being built with these tools. There's lots of different things that need to go into a model besides just knowing how to program, right? And experts, people that have been in there, I did my thesis on this, right? Experts are not necessarily good at defining what expert behavior is. They know how to do it, but they don't know how to write it. I can't go to an Air Force pilot that's been a pilot for 30 years and ask him to write his behavior down on a 30-page Word document. It won't get there, right? You need on the other end there knowledge engineers that can be able to ask the right kind of questions to determine how that knowledge is, where it is, what it is, how it interacts, that sort of thing. So I guess I don't want to be the bad guy, but that's a tool is a piece that you can use, but it's certainly not sufficient to say, okay, now I can finally build these rich models that I've been hoping for.
A lot of it would depend on the domain too.
Some are easier than others, for sure.
Physical domain versus a knowledge domain. You use a different set of tools. You have to develop a different set of motions. If it's a physical domain, you teach somebody how to operate a machine, or just teaching them a different language or technology. That's another methodology. It seems like be a good thing to pursue.
but you know, maybe we're still not there yet. I mean, like path planning now has some very good tools, but you know, that wasn't there 10, 15 years ago.
But it's a really well-defined problem, right? It's
Right. So we haven't really well defined these problems yet. So maybe that's the
Maybe it's
The
a set
problem
of-
of how to make all behaviors.
yeah, that's right.
Well, the natural thing I think of when we go down this path is, you know, where research has come and where the methods have evolved now for things like targeted, you know, task analysis, right? For lots of purposes. But if you're going to do CTAs, you damn sure going to do it with one expert. Okay. So the notion of being able to do that almost, I was just thinking up here, it's almost similar to what you're doing, Greg, in terms of running lots of iterations. But in this case, it's actually trying to do cognitive task analysis from lots of experts and then be able to meld those into what would be considered a consistent set of cohesive behaviors that are representative. Notice I didn't say just represent, are representative of the body of expert behaviors. So you kind of know what is generally right and what is generally not right. That's not a skill set that's been put into a box yet.
So there's a question up here in the front.
Well, comment about more about how to develop AI, and it piggybacks off of a couple things that you said, looking at modularity and hierarchical composition whenever possible. So, for example, you know, just talk about pathfinding. That's a very computationally intensive process that can be shelved off. So make a module for that. Situational awareness, target prioritization, or targeting, things like that. And then you can say what are the things that we need machine learning on, what are the things we need cognitive architectures on, and then just use it piecemeal. And then instead of having this big AI, you have these pieces that all work together, and you can get a lot more emergent behavior that way.